grade 10s, and welcome to today's show on equations and inequalities. Now, the great thing about equations and inequalities is that you're not actually really doing anything new. You're just applying everything that you've learned already. So let's start by taking a look at a mind map I've drawn and put some information on it. Okay, so in algebra, and especially in grade 10, we're going to be working with linear equations, quadratic equations, linear inequalities, and simultaneous equations. Now, you've actually done linear equations since grade 8. They're ones that only have one variable generally. Sometimes they have more than one, but that variable will have a highest power of 1. In other words, it will have a degree of 1. And you probably haven't spoken about degrees of equations and expressions since you were in grade 8, but now you know why it's important. Now, quadratic equations will have a degree of 2. In other words, it's going to have a squared in it. Typically, we see a lot of x squareds, but sometimes we see y squareds and a squareds and b squareds and things like that. Now, grade 10s, I want you to look me in the eyes when you hear this. When we do quadratic equations, we work from the basis of anything that's multiplied by 0 is going to be equal to 0. So that means we're going to take all of our values in the equation, take it all to one side, and make all of it equal to 0. Okay, so that's step 1. Make everything equal 0. After that, we're then going to factorize all of those terms until we eventually get to a point where everything is being multiplied by something else. And the reason we do that is because anything that's multiplied by 0 will give you an answer of 0. So that means we can solve for the brackets individually. So if we had x minus 3 times x plus 4, if x were 3 or x was minus 4, the equation would be equal to 0. It doesn't really make much sense when I'm looking at you, talking to you about it, but when we do it in an example just now, you'll see what I'm talking about. And that moment is now. So I'm going to pretend that we've been working with a quadratic equation, and we have now got to the point where we factorized it into x and x minus 3. Now, if we think about it, this is all equal to 0. So that means if this x had a value of 0, then this equation would be true. And that's what we're aiming for. We need to find the value of x that will make it 0. That will make the equation 0. But if this bracket over here were equal to 0, in other words, x was equals to 3, then the equation would also be true. So we have two possible values for x. We have x can be 0 or x can be 3. Solving equations is all about making the value of the variable in such a way that the statement is true. So an equation is a statement. It's saying that this is equals to this over here. But when we're solving equations, we're trying to find the missing value that makes this whole statement true. And that's why we're solving for x. Now, inequalities are quite similar. We're also trying to find a value for x or any variable that's there that will make the statement true. But instead of the statement saying this is equals to this, the statement's rather saying that this is more than this. So if we think about this logically, it usually means we're going to have more than one answer. And it's not like a quadratic equation where we've got two answers. It'll probably be multiple answers that will stretch along a timeline, or not a timeline, a number line or something like that. So maybe all of the values of x that are between 3 and negative 5, or negative 5 and 3. So it could be negative 2.5. And then we would use an inequality to represent that. We treat linear inequalities in exactly the same way we would treat linear equations. And you remember in grade 8, when we're solving for x, if it was 2x plus 3 is equals to 7, we would start by taking over the 3 and then get rid of the 2. And we do exactly the same thing with linear inequalities. Let's draw this problem just so that we can see what I'm talking about. So I said 2x plus 3 is equals to 7. Okay, we first need to get rid of the 3. And I tell my classes that, you know, solving an equation is all about getting the girl. There she is. And of course, if you want, it can be a boy. I don't really care. But it's all about making that connection with a special someone. In order to get to that someone, you first have to get rid of the friends. So who is the friend? Here is the friend. We don't like the friend. We send the friend to the other side. Now mathematically, what we're doing is we're subtracting 3 from both sides of the equation. But of course, we never talk like that. We just say we're going to move 3 to the other side. It's not moving. We are subtracting it from both sides, but we're lazy, so we only show that part. So now we have 2x is equals to 7 minus 3, which is 4. Okay, we have our girl or boy alone. What do we want now? We want to get rid of those inhibitions. We want to make her or him feel comfortable enough and happy enough so that they will actually say yes when we're going to ask them to go to the dance or the movies or whatever you want to do with them. So the way we do this is we make them laugh. We get rid of their inhibition. What is the thing that's stopping the X from having fun over here? Let's take a look. Ah, you see that over there? This girl is carrying some baggage. How are we going to get rid of that baggage? Well, the 2 is multiplying the X. So in order to get rid of the 2, what we're really doing is we're dividing both sides by 2. But because we are super mathematicians, we don't like to show those kinds of calculations. We just talk about moving the 2 to the other side. And because it's multiplying on one side, it's going to divide on the other, which then gives us an answer of x is equals to 2. Okay, now grade 10s. The same way we've done a linear equation, we are now going to do a linear inequality. In fact, I'm actually going to be a bit sneaky, and I'm just going to change the equal sign to an inequality sign. So I'm going to go all the way to the top of this question that I developed, and I'm going to make this more than or equal to. So this side over here is bigger in value. It has a greater value than this side over here. It's smaller. Okay. Now, I would have started by taking the friend over, and I still do that. I still take the friend over. Nothing has changed about the inequality sign. Then I would have gotten rid of the 2 in front of the x. I still do that. Nothing has changed about the inequality sign. And lastly, 2 divided by 4 gives us 2, which means that x is going to be more than 2. So our sign hasn't actually changed direction the whole way through. We've treated it in exactly the same way as an equal sign. The only thing that is different from an inequality sign and an equal sign, or the only time we treat them differently, is when we multiply by negative numbers. If we multiply or divide by a negative number on both sides of the inequality, the sign will change the direction. Okay, so I'm going to show an example of this, and I'll do it in green over here. Let's say we rather had 2x is more than or equal to, let's make it 8. So I've made a new problem. I need to get rid of that negative 2 on both sides. So I'm going to divide by negative 2. And remember that usually we don't write that at all. We just do the calculation. And once I've divided by negative 2, my sign will change direction. Okay. And there we go. That's the only thing that's different. So just remember, the only thing that's different about a linear inequality is when we multiply or divide by a negative number, the sign changes direction. Okay, the last thing we're going to learn in this section are simultaneous equations. Now, simultaneous equations are equations that are done at the same time. So let's say I had two variables in the equation. I had y is equals to 3x plus 7, and I had x is equals to 7y plus 3. I would need one equation to solve for the other equation. In fact, you can generally say the number of variables you have will be the number of equations you need to solve for them. So if I had two variables, x and y, which is what you'll usually have, I would need two equations. If I had three variables, I would need three equations. And 5 variables, 5 equations. Luckily for you, in grade 10, we stick to 2 variables and we stick to linear equations. Once again, that's any equation where the highest degree or the highest exponent is 1. Okay, so with simultaneous equations, there are 3 ways you can solve for them. You can either do it graphically, it's very time consuming and not worth the effort, or you can solve for it with elimination. It's not my favorite, but some people like it. And lastly, my personal favorite, and I think the method that, well, in my opinion, works out the best most of the time, is solving by substitution. And that's when you take the one equation and make it equal to the other, or substitute it into the other. And we do have an example of that today, so we'll get to it. Let's look at what our challenge question is for this week, and remember that we will be going through these challenge questions in the last show of the term. So this challenge question says solve for x. There's an x, and there's an x. ax minus bx is equals to 2a minus 2b. And then it has some criteria. If a is greater than b, or if a is less than b, or if a is equals to b. Okay, let's erase my dots. Take a minute to take a look at that, maybe write it down. I hope you wrote that down and you're ready to do it at the end of the term. Shall we look at the questions that we've got to do today? We're going to start by solving some equations. The first one is x squared is equals to 25. Then we have a long one over here, 7 into brackets x minus 2 minus 2 into brackets 7 minus 3x plus 2 is equals to 0. Then we have x squared minus 2x minus 8 is equals to 0. And lastly, a fraction. And we all know what fractions are. They're grannies in bikinis. Everyone loves their granny, but no one wants to see them in a bikini. So, grade 10s, while you're having a break now, why don't you try some of these out? Get a bit of fresh air, and we'll see you just now. Did you have a good break? Did you get some water, some exercise, get the brain flowing every now and then? It's a really good idea to get up every now and then, stretch your legs, stretch your fingers out like this, wiggle them, just get the blood flowing again. It helps you to think. Okay, let's go back to these questions and solve some equations. The first one we're going to look at is x squared is equals to 25. What type of equation is this? Remember I said there were two types of equations, linear equations and quadratic equations. So which one is this? How do we tell? We've got to look at the degree of the equation, and this one is to the power of 2, which means we've got an x squared. You see, quad and squared, that's how we know it's a quadratic equation. The whole thing behind quadratic equations was that we had to make it equal to 0 before we could solve it. So I'm going to demonstrate how to do that with this question, and then a little later on, when you've got that other quadratic equation, I'm going to let you try by yourselves. So, quadratic equations, step 1, make it equal to 0. Let's do that. Okay, step 1, make it equal to 0. I'm going to take x to the other side, or x squared to the other side. And you know what? I have made this look really ugly for myself. Now, maths is all about making things easier for yourself, and I want to do that. So I'm going to take out a common factor of -1. The reason I'm doing that is because then I'll have a positive x squared, and that will just make me happy. Maths is all about making you happy. I'm going to get rid of that -1 by dividing both sides by -1. Now generally you don't have to show that calculation, but because I'm a fantastic maths teacher, I've put it in there. But I've also put it in there in blue so that you know it's not essential. In fact, you could have actually skipped this step altogether and gone straight to this step, where I have x squared minus 25. Now grade 10s, you'll remember that there are multiple different types of factorizing that you've got to know. There is taking out a common factor. There's a difference of 2 squares, trinomials, and sum or difference of 2 cubes. Generally, when solving equations, we won't give you a sum and difference of 2 cubes because it doesn't really solve nicely. So we reserve those for simplifying expression questions. So with solving equations, watch out for your common factors, for your difference of 2 squares, and your trinomials. And obviously, this question is a difference of 2 squares. I've got x squared, and I've got 25, which is 5 squared. Let's go back to the drawing board. So we have 0 is equals to, and my difference of 2 squares will result in x minus 5 and x plus 5. Okay, grade 10s. Now remember what I said in the beginning. Quadratic equations are all based on the principle that anything multiplied by 0 will be equal to 0. So now I've factorized this equation so that I have 2 terms that are being multiplied by each other, 2 brackets that are being multiplied by each other. If this bracket is equals to 0, that would make the equation true, because it would mean that this times this would give me an answer to 0, and the equation is equals to 0. But at the same time, if this bracket is 0, this bracket times this bracket will give me an answer of 0, and that would give the equation meaning and purpose. So the next thing I'm going to do is find out what the values are for those brackets that will make them equal to 0. In other words, I'm going to take this bracket over here and make it equal to 0. X minus 5 equals 0. And I'm also going to take this one. So I've got two different calculations that are happening here, and make that equal to 0. So in this equation, I'm taking 5 to the other side, where it becomes positive, and this 5 over here is adding, so when it goes to the other side, it minuses. Okay, so when I solve an equation, I'm finding a value for the variable that will make the equation true. In this case, I found two values, and I know I will find two values because it's a quadratic equation, so that indicates that there will possibly be two values. Sometimes it works out to be one value. It is what it is, and when we get to functions later on in the year, you'll see why, so that's something to look forward to. Now, let's go back to the rest of those equations, and I would like you to try these other three. This one, and this one, just quickly by yourselves for the next 3 minutes. So how did it go? Do you think you got it right? Well, I can tell you that the first answer is x is equals to 2. Shall we see how that happened? Okay, now we have done question A already together, so we're going to go to B. This is a linear equation, and I know that because when I multiply these brackets out, this one and this one, I'm just going to have x to the power of 1. Let's see. 7 times x gives me 7x, and 7 times negative 2 gives me negative 14. Now let's go to this bracket. Negative 2 times 7 gives me negative 14. And negative 2 times negative 3 gives me, and watch out for this, positive 6x. I've still got this plus 2 on the end that I mustn't forget to put in. And look at that. All of our variables have an exponent of 1. We don't write it there usually because mathematicians are lazy and we don't want to write things that we don't have to. Okay, I'm going to underline my like terms. What is 7x plus 6x? Well, I've got 7 of x's over there, and I'm adding 6 x's, so that will give me a total of 13x. And now, what is minus 14? Minus 14, that's going to be minus 28, plus 2 is going to be minus 26. Okay, now grade 10s, remember, solving linear equations is all about getting the girl. Before you can even hope to get there, you first need to get rid of the friends. What is the friend doing on that side? Well, she is minusing, which means that she will be adding on the other side. Remember, mathematically speaking, we have actually added 26 to both sides of the equation, but we just don't show it. Why? Because mathematicians are lazy, and we pride ourselves in being lazy. Okay, now that we've gotten rid of the 26, we need to get rid of her inhibitions. We need to make her laugh. And in this case, she is carrying 13 as baggage. Now the 13 is multiplying the x, which means in order to get rid of it, we're going to divide both sides of the equation by 13. And that will give us x is equals to 2. Okay, so that was quite simple. Actually, you could have expected to see a question like that in your grade 9 exam. Let's go to the next question, which required some factorizing. And the reason it required factorizing is because it was to the degree of 2. So that tells us it's a quadratic equation. I know this needs to be a trinomial, done as a trinomial. I've got 2 factors of x squared, which are x and x, and now I need to list my factors of negative 8, and I'm going to try negative 4 and 2. Negative 4 times by 2 does give me negative 8, and x times by x does give me x squared. Now I need to use these to figure out if I can make the middle term. X times by 2 gives me 2x, and negative 4 times by x gives me negative 4x. If I add those together, do I get the middle term? Yes, I do. So that means my brackets are x minus 4 and x plus 2. Now grade 10s, your maths teacher might have taught you a different method to solve for a quadratic or a trinomial. You must go with what you've been taught in class. This is the method that I teach my students, and it does take a little while to get into the flow of things. But these things come easily after a lot of practice. So practice it, practice, practice. When you're at home, just do a couple quickly. Just try it out. Okay, let's put this down. And while I'm putting this down, I'm going to remind you that solving quadratic equations is all about making it equal to 0. Why? Because anything multiplied by 0 will give an answer of 0. So that means if this bracket over here had a value of 0, the equation would be true. And if that bracket had a value of 0, so x plus 2, the equation would be true. So that means we're going to have 2 possible answers. They'll either be 4 or minus 2. Okay, let's do the last one quickly. Now this is not a difficult question, but it is a granny in a bikini. It's something we like but we don't like to look at. And the thing that's disturbing me is that 3. So the first thing I'm going to do is to put everything over a lowest common denominator of 3. So that means I have x plus 5 over 3 plus, and now I'm going to put this x over 3, which means I'm going to make it into 3x over 3. Okay, and that is equals to 1, which I don't like. I'm going to change that to 3 over 3. Now grade 10s, I'm going to stop it over there, let you have a little bit of a break, and then we'll come back and we'll finish off this question and we'll go to simultaneous equations and inequalities. Enjoy yourselves. Welcome back grade 10s. I hope you're feeling refreshed now and you're ready to solve the rest of this equation. Now just to recap, we don't like fractions, and it's not because they're difficult, it's just because we don't like the way they look. It's like when you've got a pimple on your nose. No one likes having a pimple on their nose. The face is beautiful, but everyone's still going to look at the pimple and think that something's gone wrong. So that's what this fraction is. So we just have to get rid of it, because maths is all about making it easier for yourself. And the way we do that is we find the lowest common denominator. Our lowest common denominator was 3. And now, because everything is over the same lowest common denominator of 3, we can do what some people refer to as dropping the denominator. Really, we're not dropping the denominator. What we're doing is we're multiplying both sides of the equation by 3 to get rid of the denominator. But it looks like a magical disappearing act. Let me show you what I mean. So, in this dropping the denominator, it would change to x plus 5 plus 3x is equals to 3. And the reason we can do this is because we have the same denominator the whole way across the equation. What we've actually done is we've multiplied both sides of the equation by 3. And that has got rid of the denominator. Okay, now let's add our like terms. X plus 3x is 4x, and I'm going to save time by taking the 5 over immediately. The 5 is adding on this side, so it means it's going to minus on that side. So it's 3 minus 5, which means it's equals to negative 2. Now, I've got the girl, but I need to get rid of her inhibitions, so I'm going to get rid of that 4. The 4 is multiplying the x, which means when I take it to the other side, I'm dividing by 4, giving me an answer of x is equals to a negative half. Okay, once again, remember that we have just found the value for x that makes the equation true. That's the whole point of solving an equation, is to find out what x should be so that everything else makes sense. Okay, the next question we're going to do is a simultaneous equation. You'll notice that there are 2 variables that we need to solve for. That means we need 2 equations to solve for them. Now, in each of those equations, the x will have the same value in both, and the y will have the same value in both. Let's take a look. The question says, find the values of x and y if 3x plus y is equals to 2 and 6x minus y is equals to 25. Now, in class, you might have already spoken about ways to solve for simultaneous equations. They include plotting them on graphs, and in this case, it would be 2 straight lines that would cut somewhere. This way, it takes a lot of time, and it's because we can't draw accurately, it's very difficult to read those answers off. So we don't really talk about that much other than for these 2 minutes now. The second way is by elimination, and a lot of people enjoy that method, and this question would actually be very easy to do with elimination. But we're not going to do that with this question, because my favorite way is substitution. And so, are you ready? Let's do it. I'm going to start with this equation over here. and I'm going to rearrange it. I'll leave y on this side, and I'll take the 3x to the other. And the reason I've done that is because maths is about making my life easier, and y equals just looks so much nicer than that other thing that was over here. It looked ugly. Now you'll notice I've labeled this equation number 1. This is the name I've given to the equation. Now if this one is called number 1, the second equation I'm going to call number 2. And the reason I've done that is because mathematicians are lazy and we only want to write down small sentences. And this small sentence is going to say subs 1 into 2. So grade 10s, I have now told the person who's reading my work that I'm taking equation 1 and I'm going to put it into equation 2. That means wherever I see a y in equation 2, I'm going to replace it with the value of y from equation 1. And that means there will be no more y's in that new equation. That means I can solve for x. Let's do it. Okay, so let me just circle my value of y and circle the y over there so that you can see what we're going to be replacing. The rest of the equation stays the same. I've still got 6x minus something is equals to 25. But I've replaced the y with 2 minus 3x. Okay, and let's solve this as quickly as possible. I'm going to multiply in that negative, giving me negative 2x and plus 3x is equals to 25. It is a linear equation, which means I need to have all of my x's on one side and all of my numbers on the other side. I'm skipping a few steps here, but you are all old enough and ugly enough to do it as well. Giving me an answer of 27 divided by 9, which means that x is equals to 3. Okay, a common problem over here is that often people think, okay, I've got an answer for x now, I'm done. Not so. How many variables do we have to solve for? We've got 2. So don't stop halfway through. You're not going to get all your marks. Remember that you've got to substitute the value for the variable that you found back into one of the equations. The question is, which equation is the right equation to choose? And I phrased that in a tricky way because the truth is both equations are right to use. It's all about which one will make you feel better when you use it. So when you choose the equation that you're going to substitute in, choose one that makes you feel good, because maths is all about making you feel good. So let's look at the equations. One of them was 6x minus y is equals to 25, and the other one was y is equals to 2 minus 3x. I don't know about you, but I really like number 1. I far prefer it over number 2. So I'm going to tell the marker, or the person who's looking at my work, that I'm going to substitute the value of x, which is 3, into equation 1. So that means I've got y is equals to, and let's quickly go up to check it again, 2 minus 3x. 2 minus 3 times 3. And that will give me an answer of 2 minus 9, which is minus 7. Okay, one of the great things about simultaneous equations is if you do the steps, you get it right. You just have to keep a cool head and practice enough so that you get it right every time. Okay, now the moment you've all been waiting for, let's look at a linear inequality. Question says solve for x and illustrate your number on a number, or illustrate your answer on a number line. And we have an inequality of x plus x over 3 is smaller than 11 minus x over 2. Okay, I'm going to give you a bit of a project. I want you to do this as an equation. So I've written it out now as an equation, and I'm going to give you, let's give you 2 minutes, and we'll see you in 2 minutes and see what you've done. So how many of you tried it as solving an inequality, and how many of you did it as an equation? Which one made it easier for you to cope with? I'm guessing most of you are saying doing it as an equation rather than as an inequality. And that's a pretty normal feeling to have. Fear of the unknown is very real in mathematics. And so it's important that you come to terms with the fact that there are going to be moments that you feel scared and overwhelmed. And that is completely normal. It doesn't mean you can't do it. Not at all. It just means something looks funny. Okay, so I'm going to do it from the point of an equation. And then I'm going to show you how the inequality is exactly the same. So let's look at the stuff that I've written by hand over here. Now the big problem I'm seeing are the grannies in bikinis. I've got fractions. I've got a fraction with a denominator of 3 and a fraction with a denominator of 2, which means the lowest common denominator for this equation is going to be 6. So I'm going to change everything to have a denominator of 6, which means I have 6x over 6 plus 2x over 6 is equals to 66 over 6 minus 3x over 6. Okay, now you'll remember from the previous example, because all of our denominators are the same, we can drop them. And the way we drop them is we're actually just multiplying both sides of the equation by the denominator. And this gives us 6x plus 2x is equals to 66 minus 3x. Okay, it's a linear equation because all of the exponents have a power of 1. So that means I now have, let's add these like terms, 8x, and bring the 3 over, and it was minusing on that side, which means it's now adding on this side. 8x plus 3x is equals to 66. What is 8 plus 3? Well, that's 11x is equals to 66. And I hope that you know that then means, let's just scroll down, that x will be equal to 6. And the reason it is because 66 divided by 11 is going to give us an answer of 6. Now, the problem is, this was not an inequality problem to begin with. I mean, not an equation to begin with. It was an inequality. So let's do it now as an inequality. I'm just going to draw a line down over here. And the first thing we did with the equation was we found a lowest common denominator. And that's exactly what we need to do over here as well. I'm going to do this in purple, just so that it sticks apart. So I've got 6x over 6. My line disappeared. There we go. Plus 2x over 6. Now that's going to be less than 11 minus x. Oh, sorry, not 11 minus x. I'm changing it to a lowest common denominator, so that's 66 over 6 minus 3x over 6. I'm going to drop all of the denominators, and that means I've now got 6x plus 2x is less than 66 minus 3x. Now I'm going to gather all of my x's together, so that's 8x plus 3x is less than 66, which means I have 11x, which is less than 66. And now I'm going to get rid of the 11. It's multiplying the x, which means it's going to divide. 66 divided by 11, well, we've just done it, and we got an answer of 6. Now, if we examine the calculations, they are exactly the same. Absolutely the same. Nothing different. So I'm going to say it again. The only difference between an inequality and an equation is when we multiply or divide both sides by a negative number. It must be a negative number. Then we're going to change the direction of the inequality sign. That means if it was this way, it's now going to be this way. Or if it was this there, it's now going to be this way. So when we multiply or divide by a negative number, then the direction of the sign changes. Now, we've got very little time left, so I'm going to quickly look at the last question because it's an interesting one. There are 3 parts to this inequality. To get rid of, we need to get the x by itself, which means we need to get rid of the friend. In order to get rid of the friend, we need to subtract 3 from all 3 parts, giving us negative 6 is less than or equal to negative 2x, which is less than or equal to 11. Now, to get rid of that negative 2, we then need to divide all 3 sides, or all 3 parts, by negative 2. And what did I say about dividing or multiplying by a negative number? It's going to change the direction of the sign. So negative 6 divided by negative 2 gives us positive 3, and the sign changes direction. And look, the sign changes direction over here, and we have negative 11 over 2. Now, generally, grade 10s, what I then do is rearrange it so the negative number came first and it just flowed nicely, but we have run out of time. Grade 10s, it's been wonderful seeing you again, and I look forward to teaching you again next week. Goodbye.